All right, so this question's asking us to write a function in the form y equals a to the x. So it's kind of, I would call this y equals b to the x, and they're kind of just assuming that the coefficients on all of these are 1. And that actually does make sense because you can see all of their x-intercepts, or sorry, not x-intercepts, y-intercepts are 1. So that goes along with kind of what we learned. So then I would just kind of use the other point then to figure out what the base of the exponent is. They're calling it a. It doesn't really matter what you call it though. So I'm just going to say on number 15 here, 1/5 equals b, we don't know, but it's to the -1 power. And so you can write that as 1/5 equals 1 over b. And then it's pretty clear to see that b is 5. So I would just write this as y equals 5 to the power of x. You can see it is exponential growth, so we should have an a value or a base greater than 1. So the next one here, same idea. You can write it as 8 equals b to the power of -3. And so you could say 8 over 1 equals 1 over b to the third. You can go ahead and cross multiply here. And so it would say 8 times b to the third equals 1. You can divide by 8. So b to the third equals 1 over 8. And then you can do a cube root. And so b would have to equal 1/2. So I would just say y equals 1/2 to the power of x. All right, next up here, number 32. So for this one, I'm going to start off with my 0, 1, and then 1, base. I see our base here is 1/5, and then our horizontal asymptote at y equals 0. And then I would do my transformations here, which it looks like we just have a negative out front, so I would call that -y. I'm just going to turn all my y values negative. Now for the horizontal asymptote, I do apply the y transformation, but there's no -0, so I'm just going to leave it there. So there is the asymptote, 0, -1, 1, -1/5 would mean that it's approaching the asymptote going to the right, like so. And then it does also ask for domain and range. I already listed the asymptote right there, but domain would be -infinity to infinity. And then the range here, you can see that it's underneath that asymptote, so it's going to be -infinity to 0. Or you could also say y is less than 0 if you did it as an inequality. All right, next up, number 34. So for this one, I would actually rewrite that as -e to the x plus 1. Whenever I have an adding or subtracting number, I like to put that out back. So I'm going to do my 0, 1, 1, base. My base here is e, but I'm going to use 2.7 for that. My base is not -e. The negative is really a transformation, and I'm going to apply right there. The base itself is just e. So I have my horizontal asymptote at y equals 0. I have no x transformations because nothing's really going on in the exponent. So this is going to turn into 0 and 1, and then -1 plus 1 is 0. -2.7 plus 1 is -1.7, and then -0 plus 1 is 1. So I got my asymptote right there, and then 0, 0, 1, -1.7 would be about there. So this looks like it'll approach the asymptote going left. And then so my domain would be -infinity to infinity again for domain. And then the range would be either -infinity to 1, or if we did it as an inequality, y is less than 1. All right, next up here, they want us to use this form, which I really call y equals ab to the x. They're just using different variables there, which is fine. I know, though, that this one right here is always f of 0. It's always the y-intercept. So for number 40, I know that that's 5. And then I'm going to use my other point here to plug in for x and y. So I'm going to say 15 equals 5 times b to the power of -1. Now I'm going to divide the 5 over. So I get 3 equals, I'm going to call this 1 over b. And so I could say 3b equals 1, which means that b equals 1/3. So I could say y equals 5 times 1/3 to the power of x. All right, next up here, they are asking me to do some compound interest. So which of the given rates over the compound periods would provide a better investment? It doesn't really give us a dollar amount for this one, and so it's just saying generally which one's the better investment. So whenever this happens, I always just say P is $1. You could use, honestly, any amount that you want. You could use $100, $1,000, because if it's a better investment for $1, it's a better investment for every dollar amount there is. So I'm just going to do this kind of twice and see which one comes out better. Like I said, I'm just going to say I'm investing $1 here. And so for the compounded semi-annually, it's going to be 1 plus, and then 9.25% would be 0.0925. And then we're compounding it semi-annually to the power of 2. Oh, and it doesn't tell me t either. Okay, so once again, it doesn't tell me t, and so once again, I'm just going to use 1 for that, because if it's a better investment for 1 year, it's a better investment for 10 years. You could really honestly use any number you want, as long as you're consistent here between parts A and B. So then for this one, since it's compounded continuously, I use my E formula. So this will be 0.092, actually no, because now we're doing 9%. And then I'm going to keep my t consistent at 1. So I'll type these into my calculator and get my answers and see which one ends up being better. I like using 1 because I actually don't need to type that in. So we'll do this one, and this one comes out to 1.0946. And the other one, e to the power of 0.09, is 1.0942. So actually, this one is a little bit better. I'd rather them compound it more, like continuously, but since this interest rate is higher, that did actually make it a little bit better.